Hello. Let's see. Is everything good? Yeah. Test. See. Alright, that's good. Anyway, this is Advent of Code Day 2. Let's do this in Haskell. So, red-nosed reports. Fortunately, the first location the historian wants to search isn't a long walk from the chief historian's office, while the red-nosed reindeer nuclear fission plant appears to contain no sign of the chief historian. The engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through the molecular synthesis from a single electron. Okay, some advent of code lore that I don't understand. They're quick to add that since you're already there, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with unusual data. The unusual data, your puzzle input consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. Here is an example. Let's copy paste this. This example data contains 6 reports, each containing 5 levels. The engineers are trying to figure out which reports are safe. The red-nosed reactor safety system can only tolerate levels that are either gradually increasing or gradually decreasing, so a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing. Okay, sure. Any two adjacent levels differ by at least 1 and at most 3. That seems fine as well. In the example above, the reports can be found safe or unsafe by checking those rules. This is safe because all the levels are in decreasing by 1 or 2. Unsafe because 2 and 7 is an increase of 5. Unsafe because it's a decrease of 4. Okay, yeah, it seems fine enough. So in this example, 2 reports are safe. Analyze the unusual data from the engineers. How many reports are safe? Okay, let's exclip out example like so. Right, I have my example. Next, I can do. Let's type the main because it's just good practice. Read, let's just print, read file, example, like so. Make sure it works. Apparently it doesn't. I guess read file already returns an IO thing, so. Couldn't match type char with this. Oh yeah, I need to put this in a do. This and then print contents like so. Okay, good. Can I do lines? Split it into lines, that's great. Can I now do again map words like so? Alright. And actually it's gonna be the exact same thing as day 1, I think. So I'm going to go into day 1 and remember what I did for the parsing, which was this. Up. Good evening, Tommaso. How are you doing? So this was my the way I split the thing previously, and so yeah, map words line, yeah, that seems fine, except I think words, and now can I just do all good wrapping my head about monads? Yeah. Are you new to Haskell, or are you just like you already know about the concept of monads and you're like actually using them and struggling? Because if you're new to Haskell, I would recommend the Learn You a Haskell book, which is quite nice. It explains all the monads and applicative and so on quite well. So let's just do how do those are levels. Levels, or yeah, sure. Levels is equal to I need to type this as a double list of ints is equal to map well, just map map. How did I do this? I just read the thing from S. That worked? I'm surprised. Map read S. I don't think that will work. I think I could do something like map, something that someone recommended in the comment of the previous stream. I use them in Scala 3, but Haskell is next level syntax. Yeah, I've never used Scala, so I couldn't tell you much about it. I just know that it mixes functional programming with other paradigms. But yeah, in Haskell it's not too bad. Once you get the hang of it, it's just basically you have to, yeah, you can chain them or like reuse the output of the previous expression or ignore it basically, and the do is kind of like syntactic sugar for chaining them. Will that work? Last statement, yeah. Print levels. That did work, which is quite awesome. Yeah, and so that's more like records. I think in the thing. Reports, sure. Let's call it records. So now I need to check if they're in all in descending order. So I can sort it like can do let is increasing is equal to I guess now I can just do another function which is called is valid record, which will take a list of integers and return a bool. Is valid records will be, so we have our records, our record there. Let's just print the records here so that it compiles. This valid record is equal to R, and we are gonna do sort R is equal to R. So if the sorting is the same, or the reverse and sorting of R is equal to R. So that's like in decreasing order. So if either of those statements is true, that's good. I mean, there is another condition, but I'll do that one later. And let's just do like print is valid record records. I forgot how you do this. I think head is good. There is no sort. I think I have to import data list, if I'm not mistaken. Couldn't match actual type. First argument, maybe I just need to do this. Okay. And so indeed the first record is true. Can I map is valid record to records and just print that instead. So now I have almost what I want, except that I need another condition, which will be, can I do this actually? Is this valid syntax? Can I put it on? Okay, nice. Is this valid syntax? That's good. So we need, actually we can do this. So I need this, and I need the difference between each thing to be less than 3, if I remember. So, how can I do this? Isn't there like Google is like the Haskell search engine, so everybody, if you're ever looking for some function that you would like to use, that's probably the thing where you can look it up the easiest. Isn't there like a scan function? Data conduit list. Maybe. Oh, I can just zip it with. So I can use zip. I can probably use zip with. So can I do like zip r with like tail r, like so? So just so I remind myself. So if I have x's is equal to 1, 2, 3, like so, and I do tail x's, that does return me the tail. And if I do zip x's and tail x's, that will give me the pairs of all the numbers. Man, stop spoiling, I was about to do that. Yeah, I was going to do the thing you just recommended. And then I have to, so let's just make sure it actually works here. So if I do this, I have the difference between each of them, and I just need to make sure that this difference, I can just make sure that this difference is, can do all, I think it's all, right? All takes a foldable and a function that returns a bool. So here, let's just say D for difference, and we can say absolute difference is lower than 3, I think. Oh, I forgot what the thing is. Any two adjacent level differ by at least one. At least one, and at most 3. So must be greater or equal than this, and must be, no, greater or equal to 1 and lower than 3. I think that's it. And this is an error because why? Oh, probably because I need this. Couldn't match with actual type bool. Couldn't match expected type bool with actual type b. So doesn't that return a boolean? All. GHCI. So let me just go back to my GHCI thing. So now I have this, and let's say these is this, the nuts. Anyway, and can I just copy paste my thing? And I apply that on these. Then it's true. So it seemed to work. Is this just an indentation thing that I... Oh, maybe, like, since I use a dollar, there is some problems. Okay, right. The dollar was the problem. Hi, hey again, Lauren. How are you doing? How are you doing? Can I, Haskell, check if number in range? Wasn't there the LM thing? I don't know, I'm already doing like code golf, but I was wondering. So if I do 3, what is it? LM 1, 3, something like that. Ah, okay, there is this. So I can do, instead of this thing, I can do LM, and I think it's 3. So is it inclusive, the range? Oh, so 2. Uh, I'm doing too good, or had already too much beer. I don't know if mixing beer and Haskell is the greatest idea, but you know. Uh, Can I? Anyway, let's do the code golf later, and let's just quickly solve this. So this seems to... it's not good. Damn. Or even with beer, you... Ah, it should be in this is at most 3. So... oh, right. Right. So yeah, I think that's good. And now can't I just count? Oh yeah, that's again the filter length thing. It's unfortunate that Haskell doesn't have just a count function. That would be quite handy, I think. So length, length, filter, et I'm sure I can just do this. So yeah, can filter the records by this, and it's 2. So it worked. Can I do fetch inputs for day 2? Get inputs. This is my input. Great. Can I run this on inputs? Run it again. Copy the number. And let's see if it's correct. That's the right answer. God, I love Haskell. That's pretty good. Continue to part 2. The engineers are surprised by the low number of saved reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety system tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rule apply as before, except if removing a single level from an unsafe report would make it safe. Same rule applies as before, except if removing a single level from... oh, okay, so I just have to do like the same thing, but I remove like one level. Like I tried by removing one level each time, I think. Would make it safe. The report instead counts as safe. So this is safe by removing the second level 3. This is safe by removing the third level 4. We got a gold star, good. Now the fun starts. I think it will be... that doesn't sound too bad. That does not sound too bad. So I just need to do to reuse my isValidRecord function, and isValidRecord and create just another one, which will be again, it will take a list of integers and return a bool, and this one I will call tolerate, because why not? And it will take a record, and it will just try the isValidRecord with one removed all each time. How could I do this? Could I just split this into, this is a level, this is the other levels, and can I try like, and we bind this to R, like so. I forgot if you need the parentheses for this. I don't remember. I don't remember, so I'm just gonna use this for now. So I do need the parentheses. Yes, I do. And so now I can do so it's like is valid record or is valid record else, or if that doesn't work, we can do is valid record L concatenated with tail else, like this. Does that sound good? Does it compile? It does not. Do I need this? Yes, I do. And so this will be result 1. Result 2 will be the same thing, except we use tolerate, and here we print f, et part 1, this. Whoops, no commas in Haskell, my bad. Result 1, this part 2, result 2, yes, and there is no printf because I need to import data text. By the way, I should get into the habit of like not including the whole thing. What wasn't it? Data text? Where is it? Main.hs. Oh, text printf, my bad. Text printf, like so. Okay, and from list, what do I use? I use sort. Yeah. So let's try with the example, just to make sure. Example. That's not correct because it's 4. So for this guy, I will try on this. So I will try on this. This will be false. I will try on this. This will be false, and then I will try on this, and it will be true. And for this guy, I will try on this. This will be false. I will try on this. This will be false. And then I recurse with this and this. This will be false. Oh, but now I lost the 6. My bad. Yeah, the 6 is lost forever now. So I need to try the other way as well, I would guess. Huh. Perhaps think of all combinations. Yeah, I could do like the combinations thing, but I don't know. It feels like because it's only one that it's that you can remove. Yeah, like tolerate a single bat level. So I think like some kind of simple recursion should be enough. And so here, but which one? You don't know. Yeah, I can just try all of them. That's what I wanted to do. I mean, it's probably not optimal or whatever, but for this simple struggle with the entire day to do this in C. What a day too. Yeah, C is I don't know why this would be tricky in C, but I don't know. Maybe I'll solve it first and then maybe I will understand. Can Ah. I could do it like the stupid way where I recurse with an index, but and like remove the element at that specific index, but that sounds not very Haskell-y. Uh, Otherwise, I mean, first I can try the combinations thing, I guess. Combinations. Isn't, isn't there like a built-in permutations or no, not permutations, but yeah, that's probably not it. You don't have to shut up. It is fine. Is valid record. How do I... Can I do on L? Yeah, but then I'm just gonna do like head, else, and then tail. Yeah, but then that's only gonna be robust for like one entry, not all of them. So that probably won't work. Right direction. Yeah, but try the clever way didn't work. Seemed like I'm not very clever. Tried recursion didn't work. Required procedural way. I think there is probably a way to do it recursively. But yeah, with my current thing, it works for the example. I doubt it will work for the input because I would need to do like head, tail, ls, and then like I would have to do the recursion myself basically, which is kind of silly. I can quickly try out of curiosity though, but let's try this. Boop. Yeah, of course, that's not the right answer. There is sure, but do you want to do it? Yeah, maybe I will just do the where inner I. And then how do you remove an element in Haskell? Remove. What is it? Data list. There's probably some. I really have to specify like the thing. Mon Dieu. This data list. Is there a way to remove? So dump function removes duplicate element. Nope. This function is that no. Delete first by. Delete by. So it's delete. Is there like a simple delete? Delete removes the first occurrence of x. Oh yeah, but can't I do it with an index? Delete by, delete first, delete by, delete first by. There is probably not a proper function like this, but now I should. Yeah, okay. Delete. Intersect, insert, delete by, delete first by, union by, intersect, insert by, maximum by, minimum by. Haskell, delete, from list, yeah, it is a list, with index. Remove elements by index. Yeah, okay, you have to do your own thing, and it's probably like the least optimal thing ever. Yeah, and then this guy goes on a crazy thing. I just want to remove an element by index, my dude. What is this? Come on, it can't be that complicated. It cannot be that complicated. Um... Your beloved, your beloved arrow showed up again. No, please, not the arrows thing. Seems. Have you taken a look? No, I didn't have time. I didn't have time. I really don't have enough time except a bit after work. Um, uh, uh, oh wait, isn't it just a take? Like I do like I take instead of head, I use a take. No problems, you don't need it. Yeah, that's what I thought as well. But so. Can I do this? Comment this out. Now, can I just do R for records? This we probably don't care. Well, maybe we do want to do this at some point. So we want to do on the left hand side, and then we want to do it this way as well. It's just the third way. Instead of head this, we do take something. And this will call inner with this will be transferred to another function, inner, something like this, where inner starts at 0 and takes, well, maybe inner I. So I am getting a bit confused. R if I is equal to the length of R, then it's false. Otherwise, otherwise. Is valid record. We can just take I in R and do plus plus. Is there if there is a take, is there a skip in Haskell? Skip? Is that it? Nah. Is there like there's a take? So it's in base prelude data list. Is there like the opposite of take somewhere? Drop. Ah, that's it. Drop. Which is gonna be this. Will this work? So first I will need I plus 1 at some point, I feel. So if I have my list of, can I search x's? This, and if I do, so take 2 x's will be this, and drop 2 x's will be this. So I will need to take something like this, and I start at 1. Does that make sense? By the way, if I do drop 3 on x's, I just end up with an empty list, which makes sense. And here I don't need this, I need to do, let's removed level is equal to whatever I created there. In do I call in? I'm getting lost a bit. Inner I plus one. Oh. I forgot what's the syntax with the in. Is it not in? Is there just no in whatsoever? And actually I think I can remove this because I will try all of them anyway, so what's the point? So yeah, I think I can remove this, I can just call inner directly. I can remove this. In should be fine. Maybe my syntax is broken then. Oh, and I have a triple N inner, which is not good. So if I is the length of the list, we have tried all the things and it's definitely not good. I think that makes sense. Otherwise, we create a list which is the removed level, and we return, if it's a valid record, we just return true. I mean, this will be true, and so it won't evaluate the rest of the inner, and so the whole thing will be true. Otherwise, we tried the next, to remove the next element. Let's see if this compiles. It does not. Possible indentation mismatched brackets. Do I need to align this with the beginning? Remember that Haskell's indentation rules are a bit picky. Oh, okay, it has to be like one more. Okay. And so if I do this on example, it's 4, which is correct. If I do this on inputs, I get 605. Let's try this as an answer. Oops, no space. Fuck, that's not the right answer. Okay, maybe this is trickier than I expected. So this I can remove. The fun starts. Yeah, indeed. Indeed. Because now the example is like is working, but the input is not. That's always the annoying part in advent of code. So if I is equal to the length of R, return false. Maybe I need to do like I plus 1 here. Like only if I is greater than length of R. Does this work with the example? It does. Maybe I was just missing some cases. Yay, that's the right, okay. Yeah. It's often the case in advent of code where I miss like a +1 or -1 somewhere, and it just ruins the thing. Anyway, that was it. It's not too bad, but it's always frustrating in Haskell to do those kind of basically for loop with recursions. So yeah. Thank you, Lauren. Have you already completed the Advent of Code Day 2, or are you planning on doing it tipsy? Which might be a great experience, you know. Can't I just do some kind of range? Instead of like having my own recursion, can't I just use Haskell's like ranges? I don't fucking know how they're called. I did 12 hours ago. Ah, yeah. And are you in Europe? Because like for me, like if I want to like start when I can start, it's like at 6 a.m. and you know I'm not going to stream in my PJs at 6 a.m. Germany, yeah. So it's 6 a.m. for you as well. I guess you're more motivated than me. Isn't there? Yeah. I guess making it into a range would probably just make this just more messy than here. I can actually understand it. Get up, I get up at 5:15. Yeah, I got up early as well. I just wasn't feeling like streaming with my shit morning face. So yeah. Anyway, I hate it. Also, this is just a bit silly. I should just do this directly. I should just do this directly. Boop, 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 boop. Boop, 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 boop. Or not. You... Can't I just do literally like this, since it's like a Gorn thing? This is true. Like otherwise we like this. I like to get up at 15. Data X index range, if you really want it. Yeah, I don't think I'm gonna do the index range. Data index range. Contiguous. Yeah, no, that sounds way overkill. I would like to stay with the standard library of Haskell for now as well. So why is this bad? Couldn't match expected type bool with actual type int. What do you mean? That's a bool. That's a boolean as far as I'm concerned. And we have access to I, we have access to R. What's the big deal here, Haskell? What is the big deal? In the expression is valid take in a statement pattern guard for an equation for inner. Is this in an equation for inner? Couldn't match expected type bool with actual type int. Oh, maybe I just need a Maybe it's just that the plus plus operator is low priority. Yeah, okay, that's it. Oh well. Alright, I think that's about it. Can I do something like this? Yeah, can I remove the parentheses here? Yes. And yeah, I think that's about as clean as my code can get. I would guess. Yeah, I think I'm happy for the result, with the results. Yeah, I think I'm gonna stop here. This one was quite short, but yeah. Anyway, it was nice. Anyway, I think I have to cook. It's quite late. So yeah, maybe I'll see you tomorrow if I'm not too tired. And thank you again for the help and for hanging out with me. See you tomorrow. And yeah, sleep well, I guess. See ya.